Hey everyone, so we're starting off this video with question number 18 of the semester exam review for Algebra 1. Remembering guys that in order to graph anything, and you will have to graph one digitally on the semester exam, you need to get it into y equals mx plus b first. So we're going to start out by minusing x on both sides. So we have x minus x is 0, 3y is less than negative x, and don't forget to bring down the minus 6. And then divide everything by 3. So 3 divided by 3 is y. We do not flip the symbol because we divided all of them by a positive number. So the symbol does not flip. It will stay a less than symbol. Remembering that there is a 1 here in front of the x, so it is negative 1/3. And negative 6 divided by 3 is negative 2. So we start out, remember guys, by plotting your y-intercept on the y-axis. And then since it's negative, we're going down 1/3. Down 1/3. And then go up 1 and to the left 3 to work backwards. Now this particular symbol is a less than symbol. Less than means shade below, but it does not have an equal to, so it is a dashed line. So when you're graphing digitally, you need to change the line to dashed. Sometimes, obviously not always, and it is less than, so we're shading below. And anywhere in the shaded area are solutions. Anything not in the shaded area is not a solution. So plot the points that you see over there. -1, -3 is located right here. That looks like a solution to me. 3, -3 is actually on a dashed line, which means it is not a solution. 2, 5, not a solution. -6, -8 is way down here. It is a solution. It's in the shaded area. And 4, -2 is here. It is not. So these two are the only ones that are solutions. Okay, remember, it has to be in the shaded area or on a solid line to be a solution. So this one here that's on the dashed line is not. All right. So let's have a look at systems of equations. When both of your equations are in standard form, this is when we want to use elimination method. Okay, so it means we're trying to eliminate one of the two variables. Okay, and in this case, it would probably be easier to eliminate the y's. In order for them to eliminate, we need them to be opposites. So the bottom equation has 2y. Positive 2y. So I need the top to be negative 2y for them to eliminate and add up to 0. So we're going to multiply the entire top equation by -2. So -2 times 4x is -8x. -2 times y is -2y. And -2 times 15 is -30. And the bottom equation will remain exactly the same. And now you can see, guys, that -2 and +2 add up to 0, and they do eliminate when we add the two equations together. -8 and 7 add up to -1x. These add up to 0. I don't know why I eliminated the first ones. I'm sorry, guys. That was weird. I did not mean to cross that out. -8x plus 7x is -1x. The y's cancel because they add up to 0. -30 and +30 also adds up to 0. Interesting. So when we divide both sides by -1, 0 divided by -1 is 0. So keeping in mind the solution is a point where the two lines meet, and we know that the x value of that point is 0. We don't know the y value yet. So we're going to do that now. We're going to take that second equation, 7x plus 2y equals 30. And we're replacing the x in the equation with 0 because we had just solved and found out that x was 0. So 7 times 0 is 0. It's basically gone. So 2y equals 30 is what's left. Divide both sides by 2, and we now know that y is 15. So let's add that to our point. 0, 15 is the solution where those two lines intersect at. Now, keeping in mind that you could also solve both of them and get them into y equals mx plus b form and graph them in Desmos to see where they intersect. All right, let's look at number 20. This one, since x is on its own, this is a great one for substitution method, which a lot of people liked. It's fun, I enjoy it. Substitution method is probably the best one for this particular problem, whereas the last one were both in standard form, so elimination was a little bit better. So remember, here's what you do. You look for the variable that is alone, and it's that x right there. Now, what is x equal to? It's equal to all of this, and we circle it or box it. So I can replace any x with negative 2y plus 9 because they are equal. So I'm going to replace the x that's right above it. I drew an arrow to it. It's going to get replaced with negative 2y plus 9. So let's rewrite that top equation. 6y plus x equals negative 59. And we are replacing x with negative 2y plus 9. There is an imaginary 1 here that you could distribute. 1 times negative 2 is negative 2. 1 times 9 is 9. They pretty much remain the same. Combine your y's together. 6y minus 2y is 4y. Now let's finish solving. To get rid of a plus 9, we minus 9 from both sides. So we've got, I'm going to move it over here. On the left side, we have 4y. Negative 59 minus 9 is negative 68. And then we divide by 4. And we get that y is equal to negative 17. That's the y value. Keeping in mind in this problem, it's asking you what is the x value. So we have not found the x value of this problem yet. So we need to do that. The best thing you can do is go to the equation that has x alone already. I'm going to rewrite it down here for us. Okay, x equals negative 2y plus 9. So I'm going to replace the y with what we got for y, which was negative 17. So x equals negative 2 times negative 17 plus 9. Negative 2 times negative 17 is positive 34. And then add 9 to it, and we get that our x value is positive 43. That is our answer. Number 21 is a pretty quick problem. It is just identifying the correct equations. Keeping in mind there are a total of 10 candles being bought. This one says that there are 68 candles being bought. The big candles plus the small candles is 68 candles. No, it is not. So this one says the same thing. So these ones are out. This equation is correct. The number of big candles plus the number of small candles is 10. The total money-wise, big candles are $4. You see that right here. Big candles are not $3. Boom, it is C. Big candles are $4, small candles are $3 for a total of $68. All of the money should go into the same equation. Keep that in mind. All right, let's plug a problem number 22. So in this one, guys, you can probably do one at a time. Looking at one of the graphs first, one of the lines. I'm going to look at this one right here. The y-intercept is 4. So I only see one that has a y-intercept of 4. So that kind of actually makes this one pretty easy. But it may not be as easy on the test. So then I pick another point on that line, and I find my slope. It's going down 4 over 9. So the equation of that line, K2, is y equals -4/9. That's the slope. And the y-intercept was a +4, and it's this equation right here. So I know it is A. The other one, if you care to look at it, starts at -2. That's the y-intercept. So I know part of my equation, but I also need to do rise over run. It is rising 6, running 2, and 6 divided by 2 is 3. So our slope is 3x, and the y-intercept was -2, which is this equation. Okay guys, so in this problem there are 2 equations. I only focused on just one to see if I could get the answer without having to do the other. I solved to get y alone, and you can see that -3 divided by 15 reduced to -1/5. So I'm looking for a line that has a slope of -1/5. And then the y-intercept reduced, it was 6 divided by 15, and we got -2/5. Which, by the way, if you wanted to know what that y-intercept is as a decimal, it is -0.2 as a decimal, and that's the y-intercept. So I'm looking for a line that has a y-intercept of -0.2 and has a slope of -1/5. Now, answer choice A did have a slope of -1/5, this line here, but the y-intercept looks like it's at positive. It's right here. Looks like it's at +0.2. So unfortunately that doesn't work out. It needs to be -0.2. Answer choice C and D do not have slopes of -1/5, but B did. You can see answer choice B had a slope of down 1/5, and the y-intercept is at -0.2 down here. Remember, if it's below the origin, it's negative. So this one was answer choice B. And that was the last question on your review. So if you have any further questions about any of these, please reach out to your teacher. Make sure you study every single one and you'll be great on the exam. Good luck, guys.